So the way position relates to velocity is that when you integrate your velocity in terms of time, you can get an equation for the position. This is because when you have your graph for position, I'll just use this standard graph of position of an object being thrown upwards, as will be relevant in the example problem. Your velocity is going to be the derivative of this graph, because the velocity explains the slope of the graph at a particular point of time. For more details on this, watch the video for problem 1. So this would be a graph of velocity. And so the opposite of taking a derivative is integrating. So if we want to go from velocity to position rather than from position to velocity, we're going to integrate in terms of time instead of take the derivative. So a problem which uses this as an example is question number 16 on the AP test. A ball of mass 2 kilograms is thrown vertically upward from the top of a building. The ball's velocity v is given as a function of time t by the equation v of t equals r minus st, where r equals 5 meters per second and s equals 10 meters per second squared. The positive direction is upwards. So we want to find, if the ball reaches the ground at t equals 2 seconds, what is the height of the building, because it's thrown from a building. So let me explain kind of how this would look on a graph. Rather than when t being 0, at 0, x being at 0, x would start a certain distance up, and this distance would represent the height of the building. So it would look more like this graph on the bottom than the graph on the top. But the shape is still a parabola. So we want to find pretty much the equation for position, and from there we can find the height of the building. So to do this, we want to first integrate our equation for velocity. Our equation for velocity is 5 or minus 10t. So if we integrate this, 5, we're gonna get 5t minus 5t squared plus some constant c. So this equation in the box right there is equal to position, and you can kind of see how I got that from the initial integral I took. So we can figure out what this constant c is by using the information that the ball reaches the ground at t equals 2. So if this equation is the position, the position is 2, or the position is 0 at t equals 2, we can set this up as an equation with just one unknown, that being c, which is our start height. So 0 is equal to 5 times 2 minus 5 times 2 squared plus c. So this is what we have down there. And we're pretty much just going to solve for c. So 0 equals 10 minus 20 plus c. And then from there we get that c equals 10. So this is the math I did. So the building is 10 feet tall because in the equation for position, your constant at the end that you're adding to all the parts which are dependent on time is going to be your start height, because when t equals 0, all of the parts of that equation which are dependent on t will also be 0, and you'll only be left with your constant. So that will determine your start height, or the height when t equals 0. So this is answer B on question 16's multiple choice.